Let's start recording. Okay, what do I mean by properties of equality? Properties of equality. Yes, Eric, what do you got, buddy? Yeah, all right, very good. So there, we have a couple of properties of equality, things that we can do to both sides of an equation in legal mathematics, right? So let's talk about 4 of them right now. I'll move up on the screen. So what I'm going to do is I'm going to actually give you the property, and I wonder if you can give me the name of that property. What if I tell you something like A is equal to A? What does that property symbolize? Starts with an R. Who's got Jared? What do you got for me? Yeah, that's the reflexive property. We are allowed to say that, right? That's our reflexive property of equality. So you look in the mirror, you have a reflection, right? Reflexive A equals A. Let me give you this one. This is an if-then statement. What if I say if A is equal to B, then B is equal to A. What is this one called? Any thoughts, guesses? Just shout it out. What do you got? Starts with an S. I'll give you a hint. It's symmetric. Yes, very good. Yeah, this is the symmetric property of equality, right? So we can say, well, if A is equal to B, then it must be true that B is equal to A, kind of a logical statement. Okay, number 3, I'm going to give you the property here. So I'm going to say, okay, if A, this is my favorite one, if A is equal to B and B is equal to C, then what can I say? A is equal to C. What is this thing called? Who knows? Transitive. That one's everyone's favorite property, right? That's transitive. You got it. Okay. And then the fourth one, I'm going to tell you what it is. The fourth one is called substitution. Okay, what do I mean by substitution? Sorry, I got a little sloppy there. All right, x plus 4 is equal to negative 12. Here's what we're going to do. In addition to the 4 properties I just gave you, the reflexive, symmetric, transitive, there's also the addition property of equality. I mean, you can add something to both sides. There's also the subtraction property, right? There's the multiplication and then division, as long as you don't divide by what? 0. So you know all this. Good. All right, so let's solve this and talk about what property we're going to use here. So what would you do to solve this? Yes, sir. Go ahead. Yeah, so I would subtract 4 from both sides, right? I'm with you on this side. So what does that give me? X equals what? Next, negative 16. So we use the subtraction property of equality. All right, first step. Who's got an idea? Yeah, Jared, give us it. What do you got? Yeah, let's distribute. So let's go negative 27 plus 6y has to be what? 3y minus 9. You guys agree with that? And that's the distributive property of equality. Okay, good. What's our next step? Yeah. Lucci, what do you got? Divide both sides by 3. I think I want to do something else first before I could do that. Yes, Mary. You subtract 3y. Okay, who agrees with that? Yeah, let's do that. Let's subtract 3y from both sides, okay? So then I'm going to have negative 27. Then I have a plus, what would that be? 3y equals what? Negative 9. And what do we do? There you go. That's the subtraction property of equality. Okay, good. Then what would we do? Someone have it. Yeah, Madeline. Add 27. All right. I like that. Add 27. Add 27. So I'm going to get 3y is equal to, what's that going to give me on the other side? 18, right? Yeah, I'm definitely thinking 18. What do we do there? That's the addition property of equality, right? Very good. And then lastly, what would we do? Divide by 3, divide by 3. So we're going to get y is equal to what? I mean, I'm getting 6 out of this case, okay? And then lastly, we did the division property of equality. All right, so take about 2 or 3 minutes. Solve these on your own. Ask the person sitting next to you what they got, and then we'll discuss. All right, here we go. Let's solve it together. Eric S., what would I do first? What do you think? Move the x's to one side. What about the right-hand side? Do you see anything? What are these called, everybody? This and this right there. I've highlighted. What are those 2 things called? Talk them out. Just spit it out. Like terms. What makes them like terms? 2 things have to happen to be like terms. Name one of them. Yes. Same variable. Do they have the same variable? X's. Yes, that's true. And then the same what? Exponent. Very good. They both have an exponent of what in this case? 1. So those are like terms. So what can I do to those like terms? Add them together. You got it. So what would my next line of algebra be? 11 plus 3x minus 7 is equal to, what's 6x take away 3x? 3x, good, and then I have a plus 5. Okay, next move. Who sees it? Yes, sir, what would it be? So 11 minus 7, yeah, what would that be? Yeah, so I'm getting 3x plus 4 is now equal to 3x plus 5. What happens to the 3x's? They cancel out because it's balanced on both sides. So you end up with this statement, ladies and gentlemen. You get 4 is equal to 5. What kind of statement is that? This is what's known as a false statement. So that implies that this equation is never true. So not every single equation has to be true. So there is no value of x that would make that equation true. Because we did all the algebra, we have these properties of equality that tell us each line of algebra is equivalent to the one above it. Therefore, we're getting a false statement, so there is no value of x that could ever make that true. Sometimes you come across those. All right, let's do this one together. I've got 6x plus 5 minus 2x equals 4 plus 4x plus 1. On the left-hand side, what can we do? Who sees something? I see a 6x and a 2x. What's that give me? Yeah, that's going to give me, what, 4x, right? And then plus 5. On the other side, I see 4x over here, and then I have a 4 and 1 plus 5. Huh. Well, what do you do now? Well, 4x's go away, right? And then what else goes away? 5's go away, 5's go away. So what does this give me? This gives me 0 is equal to 0. Okay, let's compare these two things. Let's go back to the other one. How are these two statements? What's the difference between this statement here and this statement here? Yes, what do you see?
B is true.
Yeah, this is a true statement, huh? Okay, so what does that tell me about my algebraic equation up top? It works, but what does it mean by that? Go a little bit deeper. This works for what? Yeah, this is always true, right? This is always true. It'll work for any value of x that you plug in, right? No matter what you do, you'll plug in any value, it should always work. So what's an easy value of x that we could use to test this? The easiest value of x you can think of? Yeah. 3, that's the easiest one you can think of? 1? I think of an easier one. 0. What happens if you check 0? What would you get? 5 equals 5. Is that a true statement? What if I checked 1? What would I get? Computer really quickly. 9 equals 9. What if I said 3, just like Ethan said to do? 3, what would I get? Okay, so no matter what we pick, we're going to get a true statement, so therefore it is always true. So let's talk about this. Do we know what it means for an equation to be always true? We just talked about it. Do we know what it means to be never true? What does it mean to be sometimes true? Anybody have any thoughts on that? What does it mean to be sometimes true? Yeah, Madeline. Yeah, one answer, like x equals 5, right? It's true only if I actually get in a solution, like x equals 5. So now we know what all three mean. So answer these two, A and B, with either always true, sometimes true, or never true. Never true. Do we agree with Emma? This one is never true. Why? What makes this never true? What'd you get for your statement? 6 and 4. Anybody else get the same thing? Do you want anything different? What'd you get? What'd you get? Yeah. Okay, so 6 equals 4, so same thing. Okay. So never true. What about part B? I have not heard from Casey.
Yes.
Part B, what'd you get?
I got always true.
Always true. Do we agree with Casey?
Yes.
Always true. Very good. Okay, awesome. All right, this is an example of a literal equation. A literal equation is nothing more than an equation that has more than two variables in it. Who knows what this equation is? Yes, Brandon. It's the conversion from Celsius to Fahrenheit. Very good. All right, so what makes this a literal equation? Yes, sir. More than one variable. Which two variables does it have? C, and it has F. Okay, so you're going to see this terminology in the book and in math for all to come. You're going to see this terminology. It says what is F in terms of C. So you're going to see this a lot. What is F in terms of C? What does that mean? What does that mean to you? How do you interpret what that language of math means? Yes. That's what that means. Get F by itself. So when you see this, it means get F by itself. That's what that means. Alright, so here's what I'd like you to do. Right now, you and a partner, in your notes, try and get F by itself. Ready, set, go. Jake's going to show us what he did to get F in terms of C. What'd you do, buddy? So you divide the entire right side by 5 over 9. And what property allows you to do that? Yeah, the whole thing. So both sides by 5 over 9? Yeah. Kind of like that? Okay. Equals F minus 32. Can I write it like that? 9/5 C. Is that the same thing as 9C over 5? Yeah, those are the same things, right? Okay, good. Then what would you do? 9/5 C plus 32 is equal to F. And now, ladies and gentlemen, we have F in terms of C. So that means get F by itself. Fair enough? All right.